In this video, we'll learn how to write null and alternative hypotheses from a claim. We'll work through 3 examples together. As you see, every problem follows the same process. Once you learn that process, writing hypotheses becomes much more straightforward. Let's begin. Example 1. A company claims the average battery life is more than 10 hours. Express the null and alternative hypothesis in symbolic form for this claim. So we want to find HO and HA. But first, we need to identify the parameter. The claim is about the average. So the population parameter is the population mean, which is mu. Step 1. Write the claim using symbols. Let's look at the wording carefully. The phrase more than 10 hours tells us the average is greater than 10 hours. Since we're talking about the population mean, so we have mu is greater than 10. Step 2. Write the opposite statement. So I want the opposite statement of the original claim. Think of the opposite statement as everything that is not included in the original claim. If the average battery life is not greater than 10 hours, then it must be 10 hours or less. So we have mu is less than or equal to 10. Notice that we include the equal sign because if the average battery life is exactly 10 hours, then the original claim of more than 10 hours would not be true. Step 3. We need to identify HO and HA from these 2 statements. So we look at these 2 statements. We pick the one that does not contain the equality for HA. So mu is greater than 10 is HA. And the statement that contains an equality is HO. So HO is mu less than or equal to 10. These are my null and alternative hypotheses. However, here's a quick note. Many statistics textbooks, including ours, simplify the null hypothesis by just writing the equality sign. So for this problem, HO can either be mu less than or equal to 10 or mu is equal to 10. They both are acceptable. In this course, we'll follow our textbook and use just the equality sign. But if you see this in another textbook or online, that is still correct. And finally, we need to determine the type of test. Let's look at HA. HA uses a greater than symbol. This is a right tail test. Example 2. A survey suggests less than 35% of residents recycle regularly. Express the null and alternative hypotheses in symbolic form for this claim. Let's follow the same process. First, we need to identify the parameter. Since we're talking about a percentage, the parameter is the population proportion, P. Step 1. Write a claim using symbols. The phrase less than 35% means P is less than 0.35. Step 2. Write the opposite statement. The opposite statement of P is less than 0.35 is P is greater than or equal to 0.35. Step 3. Identifying HO and HA. Between these 2 statements, The one that does not contain the equality sign is my HA. So my HA is P is less than 0.35. And HO always contains the equality sign. P equals 0.35. Again, if you use P is greater than or equal to 0.35 for HO, that is still correct. Here, I only use the equality sign because I want to follow the textbook. For the type of test, I look at the inequality sign in HA. Since the alternative hypothesis uses a less than symbol, this is a left tail test. Notice that the process didn't change. The only thing changed was the parameter. We use P here instead of mu because the claim is about the population proportion. Example 3. A manufacturer claims the standard deviation of package weights is 0.5 ounces. Express the null and alternative hypotheses in symbolic form for this claim. Let's use the same process one more time. But first, let's identify the parameter. Since the claim is about the standard deviation, the parameter is sigma. Step 1. Write the claim using symbols. The standard deviation of package weights is 0.5 ounces. The word is tells us the claim is an equality. So we have the standard deviation equals 0.5. So sigma equals 0.5. Step 2. Write the opposite statement. The original statement is sigma equals 0.5. What is the opposite statement of this? That is sigma is not equal to 0.5. Step 3. Identifying HO and HA. Between these two statements, the one that does not contain the equality sign is HA. So sigma is not equal to 0.5 is HA. And the statement contains the equality sign is HO. Since the alternative hypothesis uses not equal to, this is a two-tail test. We have now worked with the three most common population parameters: mu for population mean, p for population proportion, and sigma for population standard deviation. No matter which parameter you're using, the process is exactly the same.